All right, so today we're going to do some Lewis structures of molecules that contain xenon. Now, xenon is a noble gas, so it has a full octet before it's even bonded to anything, so it should come as no surprise that these are going to be exceptions to the octet rule. These are not going to act normally. All right, so I'm just going through and finding how many valence electrons all of my different atoms have. So it looks like I have xenon, fluorine, and oxygen, which have 8, 7, 6. Now I'm going to attach everything. I want xenon in the middle. Remember, I want the lowest electronegativity in the middle. Electronegativity increases as you go to the right, except for the noble gases, right? They don't want electrons, so they have very low electronegativity. The first one should have 22 electrons. I've drawn it with complete octets, and I only have 20 electrons. To add the extra electrons, I put them together, paired up on the central atom, which is an exception to the octet rule. That xenon has 10 electrons now, but it all has formal charges. Everything has formal charges of 0. For the next one, I'm going to attach 4 fluorines. That should give me 36 total electrons. Let me complete the octet. Counting them up. I have 32. So I need to add 4 extra electrons. That's 2 pairs, again, on the central atom, and that gives me all formal charges of 0. In the next one, I have 6 fluorines, and I'm just going to attach them all. So again, that's already breaking the octet rule. 4 bonds would be a complete octet, but the central atom can have an expanded octet. We'll see how this looks when I'm done. Should have 50 electrons. I have 48, so I added 2 more to make 50. All right, this time I have 4 fluorines and an oxygen, so I'll attach everything to my xenon. What's that, 42 electrons? All right, so I'm going to count up my electrons here. There are 40 electrons here. Unfortunately, when I did this problem in real time, I counted 42, and I knew this wasn't quite perfect. So I wrote 42 here, and then I'm checking some formal charges, and then eventually I'm going to recount and realize there's actually 40 electrons. So just give me a minute here. Okay. Now I realize there's actually 40 electrons, so I need 2 more electrons. And I'm going to still look at those formal charges and figure out what I can do to make all the formal charges be 0 if possible. And I need to add 2 electrons. And what I see is that if I add 2 to xenon, I'm still going to have a +1 charge there, and my oxygen's still going to have a -1. So I am going to go ahead and put a double bond to my oxygen, and then put 2 on. So now my xenon has 1, 2, 3, 4, 5, 6, 7, 8. So that's a 0. And the oxygen is a 0. It still has the expanded octet. And I have my 42 electrons. So I did need to add 2 to the central atom. But in this case, I also wanted to put in the double bond to fix the formal charge. All right, let's see if I can do any better on this one. All right, so 2 oxygens, 2 fluorines. I'm going to assume that they need a double bond to the oxygen this time. Normally, I don't want to assume that, but in this case, I think I probably will need it since I just saw that on the previous one. So let's see what happens. I have 32, 2 more. That gives me all formal charges of 0 and just what I wanted.